In this video, we're going to take a look at example 28-7b, which deals with the full wave rectifier. So for this one, we're going to find the ripple, and we're going to start out finding out what our secondary voltage is. So V sub S is equal to the number of turns on the secondary divided by the number of turns on the primary times the voltage of the primary. In this case, we've got a 2-to-1 transformer. I'll go ahead and write that in there, 2-to-1. So this is going to be 1/2 times 120 volts AC. And that gives us 60 volts AC. Since this is a full wave rectifier and the voltage is going to split and go through both diodes, we can say that V1 is equal to V2, which is equal to the voltage of the secondary divided by 2. So that gives us 60 volts AC divided by 2, which is 30 volts. So therefore, V1 peak is equal to V2 peak, which is equal to 30 volts AC times 1.414, and that gives us 42.42 volts. So next, to calculate V out peak, we're going to take our peak voltage here and subtract the 0.7 volt drop across dial D1 or D2. And that gives us 41.72 volts. So now that we have V out peak, we can calculate V ripple. So the V ripple is going to be the V out peak, which is 41.72 volts, times 1 minus E to the negative T. And in this case, negative T is going to be 8.33 milliseconds. And it's 8.3 milliseconds because this is a full wave rectifier. So the difference between the half wave rectifier and the full wave rectifier is that C is charged twice as often in the full wave rectifier. So that also means that C has less time to discharge in the full wave rectifier. So it's going to be approximately half, which is 8.33 milliseconds. So it's e to the 8.33 milliseconds divided by R, which is 250. And then our capacitance is 500 microfarads. Okay. So once you do that calculation, that gives our V ripple as 2.69 volts peak to peak. So now for part B, which is the volts DC, we have the volts DC is equal to the V out peak minus the V ripple divided by 2, and that equals 41.72 volts minus 2.69 volts divided by 2, and that gives us 40.38 volts.